In this vast universe, where stars twinkle like grains of sand on an endless shore, we often ponder whether we are truly alone, and that question has haunted humanity since the earliest days when we first gazed up at the night sky. Just because you scoop a cup of seawater and see no fish does not mean the ocean is empty. But if you were to drain the entire Pacific Ocean and still find not a single fish, that would be truly horrifying. And we, humanity, have essentially done something similar on a cosmic scale, with the silence we receive echoing like a death knell resounding through space and time. We have scoured a vast galactic ocean, listening to the whispers of the cosmos for more than 70 years, with all the most sophisticated instruments that our Type 0.73 civilization can devise, and what we have received is only a chilling stillness that sends shivers down the spine. But recently, in the year 2025, fresh discoveries from telescopes such as the James Webb Space Telescope and projects like Breakthrough Listen have added more intricate layers of complexity to this picture, compelling us to reflect more profoundly on why the universe remains so eerily quiet. Consider that colossal stadium, a place encompassing 400 billion stars in our Milky Way galaxy, where each star is a grandstand, and upon each grandstand there are billions of planets, with conservative estimates indicating at least 10 billion Earth-like planets in this galaxy alone. Then the total number of seats surpasses our wildest imagination, and we have shone the beams of our most powerful radio and optical telescopes onto hundreds of billions of points of light, monitoring and listening intently. Yet probabilistic models, grounded in what we know about the formation of life on Earth, almost assert that at this moment there must be at least 1 billion civilizations coexisting with us in this galactic expanse. But our radars, no matter how refined, display only random noise, tiny flickers no different from stray snowflakes in a cosmic winter night. And just this past November in 2025, scientists from the University of Tokyo analyzed data from the National Aeronautics and Space Administration's Fermi Gamma Ray Space Telescope, uncovering a halo of high-energy gamma rays surrounding the Andromeda Galaxy, suggesting that we might be witnessing traces of dark matter for the first time, a finding not directly tied to extraterrestrial life, but enriching our understanding of the universe's structure, prompting us to wonder whether other civilizations could be concealed within those shadowy realms, perhaps evading detection amid the enigmatic fabric of dark matter that constitutes approximately 85% of the universe's mass and influences galactic rotations in ways we are only beginning to comprehend. That sensation, that emptiness, is akin to stepping into the Metropolitan Opera House with 80,000 seats, all the lights blazing brilliantly, everyone seated in place, yet not a single sound emerges. No breath, no rustle of clothing, no rhythmic heartbeat in any chest, no murmur of conversation. You would question whether you are deaf or mad, or worse, that the 80,000 souls seated there are in fact long dead, hollow shells frozen in time and space. And the universe presents us with three possibilities. But in truth, with the latest research in 2025, scientists have proposed additional variants, such as the recursive panopticon hypothesis, an idea that merges older theories to suggest that civilizations might be monitoring one another in an invisible cosmic prison system of recursive higher-order deterrence, where the uncertainty of mutual surveillance enforces silence, making the quietude even more intricate. And the terrifying aspect is that each possibility harbors a deeper horror than the one before it. That sensation, that emptiness, is akin to stepping into the Metropolitan Opera House with 80,000 seats, all the lights blazing brilliantly, everyone seated in place, yet not a single sound emerges. No breath, no rustle of clothing, no rhythmic heartbeat in any chest, no murmur of conversation. You would question whether you are deaf or mad, or worse, that the 80,000 souls seated there are in fact long dead, hollow shells frozen in time and space. And the universe presents us with three possibilities. But in truth, with the latest research in 2025, scientists have proposed additional variants, such as the recursive panopticon hypothesis, an idea that merges older theories to suggest that civilizations might be monitoring one another in an invisible cosmic prison system of recursive higher-order deterrence, where the uncertainty of mutual surveillance enforces silence, making the quietude even more intricate. And the terrifying aspect is that each possibility harbors a deeper horror than the one before it. It all began in a very ordinary way. at the canteen of the Los Alamos National Laboratory on an afternoon in 1950, Enrico Fermi, the man with a razor-sharp intellect who birthed the nuclear chain reaction, was having lunch with his colleagues. In a fleeting moment, perhaps due to the contrast between the monumental work he was engaged in and the mundanity of the meal, he set down his knife and fork and uttered a question that seemed simple but carried the explosive force of a supernova. Where is everybody? That question was about extraterrestrials. It echoed through the decades, becoming the Fermi Paradox, the central enigma of modern cosmic science. And Fermi's logic was not complicated, but it rested on a solid foundation of astrophysics and probability. Our Milky Way galaxy, with 400 billion stars, has existed for about 13.8 billion years. Our Earth, a relatively young planet, is only 4.6 billion years old. If life and intelligence are inevitable products of cosmic processes, if rocky planets and habitable zones are common, then there ought to have been millions, even billions of civilizations emerging before us by billions of years. A civilization advanced by 1 billion years would have an extraordinarily long time to perfect interstellar travel technology. Even if they only developed spacecraft at a modest speed, for example 1% of the speed of light, it would take merely 10 million years for them to reach every corner of the galaxy, a mere blink in cosmic timescales. But recently, in October of 2025, an astrophysicist proposed a theory that extraterrestrials might be disinterested, having ceased attempts to contact us because they perceive us as too primitive or unengaging. An idea that sounds trivial, but aligns with the data from fruitless searches, perhaps reflecting a broader cosmic ennui, where advanced beings prioritize internal pursuits over outreach to nascent societies like ours. Yet, there is nothing, no colossal megastructures such as Dyson spheres enveloping their parent stars, constructions that any Type 2 civilization could build to harness the entirety of a star's energy output, no frequency-modulated radio signals, no bustling interstellar communication channels, not a single physical trace of grand-scale intervention. This silence is a pure anomaly, and to systematize this anomaly, in 1961, the astronomer Frank Drake endeavored to quantify it through mathematics, creating the Drake equation. This equation does not provide an answer, but it breaks the problem into measurable questions, multiplying probabilities together to estimate the number of communicable civilizations in the Milky Way galaxy, wherein the number of communicable civilizations equals the rate of new star formation per year in the galaxy, multiplied by the fraction of those stars that have planets, multiplied by the average number of planets per star system that could potentially support life, multiplied by the fraction of those planets where life actually emerges, multiplied by the fraction of life-bearing planets where intelligence evolves, multiplied by the fraction of intelligent civilizations that develop technology capable of releasing detectable signals, and multiplied by the average length of time such civilizations release those signals. And when scientists, from the most optimistic to the most cautious, input their estimated values into the equation, the results are truly shocking. Even when assigning extremely low probabilities to evolutionary factors, the number is often greater than 1, typically ranging from 10 to 10,000 active civilizations in our galaxy. The minimum figure, even with the most pessimistic assumptions, is a 2-digit number. So why, after many decades of listening, do we hear only the echo of our own voices? And the latest update in 2025 from the Breakthrough Listen project reveals that they have scanned 27 eclipsing exoplanets without detecting any signals. But they remain optimistic that with the Vera Rubin Observatory coming online, we can expand the search to unprecedented scales, incorporating advanced anomaly detection algorithms to sift through vast data sets for potential technosignatures. The silence is not due to a lack of effort on our part. In 1960, Drake initiated Project Ozma, the first radio telescope directed at specific targets in the search for intelligent extraterrestrial life. He focused on 2 sun-like stars, Tau Ceti and Epsilon Eridani. For many months, he and his associates listened. The result was a resounding stillness. But humanity, with its inherent perseverance, did not stop there. In the ensuing 6.5 decades, our ears have grown larger, more sensitive, and extended in more directions. The 500-meter aperture spherical telescope in China, with its enormous single parabolic dish 500 meters in diameter, is an astonishing engineering feat, with a collecting area equivalent to about 3 standard football pitches and the capacity to process data at the rate of an immense library every second. Stephen Hawking once predicted that if extraterrestrials decide to send signals, the most likely way we would detect them is through such facilities. And just this past November in 2025, a revolutionary artificial intelligence system achieved a 600 times increase in speed for detecting signals from space, applied to the Breakthrough Listen project, reducing false positives by nearly tenfold, opening up the possibility of swiftly identifying anomalous signals, whether from neutron star pulses or potentially from extraterrestrial intelligence, thereby transforming the efficiency of our cosmic eavesdropping. Beyond passive listening, we have chosen to speak aloud. In 1977, the National Aeronautics and Space Administration launched Voyager 1 and Voyager 2. These were not merely exploratory machines. They were cosmic bottles adrift, bearing messages from a young blue planet. Each craft carried a gold-plated copper disc, etched with sounds and images representing life on Earth. The gentle lapping of ocean waves, the howling of wind through mountain passes, the roar of thunder, and the calls of hundreds of bird species. There were intricate concertos, greetings in 55 different languages, and most importantly, recordings of humpback whale songs, our oceanic poets. On the disk's surface, a detailed diagram indicated the location of the solar system within the Milky Way galaxy, marked by the coordinates of pulsars, those stable cosmic lighthouses. Hopeful that it could be decoded by any civilization possessing basic physical knowledge. 48 years later, Voyager 1 has crossed the boundary of the heliosphere, the protective bubble created by the solar wind, and is now drifting in true interstellar space. It is approximately 24 billion kilometers from Earth and hurtling away at roughly 17 kilometers per second towards the indefinite void between stars. However, even at that near unimaginable speed, the journey to the nearest star, Proxima Centauri, would still take more than 70,000 years. When that silvered vessel, a grand symbol of human curiosity, drifts through the darkness for another 70,000 years, if some entity chances upon that golden disk, what will they hear? The sound of waves, the chirping of birds, and greetings in Mandarin. It would be the final glimpse, the ultimate legacy left by a vanished civilization. But with new predictions in 2025, scientists suggest that if we continue to advance, messages like those on Voyager could be discovered and analyzed by more advanced civilizations, leading to post-detection scenarios for which search for extraterrestrial intelligence protocols are being updated to prepare, including global coordination and crisis response frameworks. But the most mysterious moment, the instant when the echo of solitude became clearest, was a specific signal on the night of the 15th of August in 1977 at the Big Ear Radio Observatory of Ohio State University, an unusual data sequence printed out on paper. The signal lasted precisely 72 seconds. It was 30 times stronger than the usual cosmic background noise, and crucially, it was centered exactly at the frequency of 1,420 megahertz. This frequency is not random. It is the emission frequency of neutral hydrogen atoms, the most abundant element in the universe. Scientists call 1,420 megahertz the cosmic water hole, a foundational frequency that any civilization knowledgeable in atomic physics might select as an international interstellar communication channel. Jerry Amon, the astronomer on duty, saw the printed sequence, recognized the unprecedented anomaly, and instinctively circled it, writing a simple, astonished word on the printout: "Wow." Thus, the Wow signal was born. It was a brilliant flash in the tranquil sea of the cosmos, but that light faded too quickly. After 72 seconds, it vanished and has never repeated, despite numerous efforts to rescan that direction with more powerful telescopes over the ensuing 48 years. The origin of the Wow signal remains a mystery. It could be a fleeting extraterrestrial signal, a greeting tossed from a distant realm, or perhaps merely an unexplained natural astronomical phenomenon, such as the hydrogen tail of a passing comet, or worse, electromagnetic interference from Earth-based devices. But whatever it is, it affirmed one thing: the universe can speak, but it chooses silence. Why do they not respond to our ceaseless efforts? And in 2025, scientists from the Search for Extraterrestrial Intelligence Institute have employed artificial intelligence to reanalyze old data, reducing noise and accelerating processing, yet still finding no similar repeating signals, thereby reinforcing the enigma and highlighting the need for even more sophisticated analytical tools. This is where the three horrifying possibilities of the Fermi Paradox reveal themselves. But with new research, we have the additional downloadable content hypothesis, a fresh perspective positing that civilizations might be trapped in developmental cycles akin to video games, where they must unlock technological levels before communication becomes feasible, rendering the silence akin to a digital barrier that must be surmounted through sequential advancements.
The first possibility, they are deliberately hiding. This is the dark forest theory, popularized through science fiction works, but grounded in a terrifying logic. The universe is not a friendly place, but a pitch-black forest, where each civilization is a hunter armed with ultimate weapons. You do not know who your adversaries are. You do not know if they are benevolent or malevolent. You know only one certainty. Any civilization daring to switch on a light and shout its existence risks immediate annihilation by other lurking hunters. In this survival forest, the first and most crucial lesson every intelligent civilization must learn is absolute silence. Emit no signals. Leave no detectable energy or material traces. Exist as ghosts, entities gliding through space without rippling the cosmic information field. Those civilizations eager to broadcast their messages, as we are doing with Voyager, may have been eradicated millions of years ago, victims of their youthful naivety. And a comprehensive re-evaluation of the dark forest theory in 2025 indicates it could be extended to include threats from artificial intelligence, where such intelligence might be the reason civilizations vanish before establishing contact, perhaps by outpacing and supplanting their creators in a runaway evolutionary process. The second possibility, they simply do not care. This is the zoo hypothesis. Consider the disparity in developmental levels between us and a Type 3 Kardashev civilization. Much like how you do not attempt to establish diplomatic relations with an ant colony in your garden. Do you bend down and explain your government or philosophy to the anthill? No, because the gulf in cognition and communication is too vast, rendering any effort meaningless or a waste of resources. For civilizations that have mastered galactic energy, our feeble radio signals or even our primitive mechanical probes like Voyager might be mere white noise, unremarkable pheromone trails. We could be a rare species, observed from afar through non-invasive devices, like a herd of antelope in a strictly protected nature reserve. Intervening in our natural development or even communicating is deemed unethical or unnecessary. And to grasp this cognitive chasm better, we must revisit Nikolai Kardashev's classification system from 1964 based on energy harnessing levels. A Type 1 civilization exploits and utilizes all available energy on their home planet. On this scale, energy consumption is approximately 10 to the power of 16 watts. A Type 2 civilization harnesses the entire energy output of their host star, often through large-scale physical structures like Dyson spheres, with energy usage around 10 to the power of 26 watts. A Type 3 civilization controls and utilizes energy on a galactic scale, with consumption up to approximately 10 to the power of 36 watts. Where do we humans stand on this scale? According to recent calculations based on global energy consumption rates, we are at about Type 0.73. We are still grappling with fully exploiting our planet's energy, not even resolving the challenge of clean and sustainable energy without severe ecological consequences. Meanwhile, a Type 2 civilization might relocate planets, manipulate stellar eruptions, or generate artificial light visible from neighboring galaxies. To them, our energy wars or petrol-driven automobiles are perhaps childish amusements. And a new study from the Penn State Extraterrestrial Intelligence Center in 2025 demonstrates that if we simulate Earth as a distant planet, advanced civilizations could detect our radar signals from as far as 12,000 light-years away. But they might choose to ignore us because we have not yet reached a noteworthy threshold.
perhaps awaiting our maturity into a more sophisticated entity. And then we arrive at the third possibility, the most frightening of all, surpassing even solitude or disdain. The third possibility, there is a barrier obstructing. This is the idea of the Great Filter. This hypothesis posits that in the evolutionary journey from inorganic matter to an interstellar civilization, there exists one or more probabilistic hurdles extremely difficult to surmount, a filter that crushes most life forms. The conundrum is where this Great Filter lies in the cosmic timeline. If the Great Filter is behind us, meaning it resides in the past, that is wonderful news. It implies that the formation of complex life, or the evolution from single-celled to multicellular organisms, or even the emergence of intelligence are extraordinarily rare events. We have fortuitously overcome that challenge, and we are among the very few victors. If this is true, the universe is truly ours, and we can aspire to become a Type 1 civilization, then Type 2, and ultimately the galactic overlords that Fermi sought. However, the terrifying part is, if the Great Filter lies ahead of us, then the cosmic silence is the coldest warning. It intimates that although life may begin easily, as organic molecules self-assemble in Earth's ponds or on icy moons like Europa or Enceladus, there is some developmental threshold that nearly every intelligent civilization fails to cross. And a paper on Archive in December of 2025 proposes 10 versions of future Earth to predict technosignatures, aiding our searches but also cautioning that the filter could be the transition to artificial intelligence, causing civilizations to vanish, with scenarios ranging from sustainable techno-utopias to dystopian collapses, each offering distinct observable signatures like atmospheric pollutants or megastructure remnants. The Great Filter ahead of us could be anything threatening the long-term survival of a technological civilization. First, technological self-destruction. When a civilization attains the level to travel between stars, they simultaneously possess the means to obliterate themselves. Nuclear weapons, artificial intelligence beyond control, biotechnology unleashing uncontrollable global pandemics, or even basic physics experiments inadvertently creating micro-black holes or draining a parent star's energy. The ability to maintain political and ethical stability long enough to transcend this self-destructive era may be so rare that only one civilization in billions of galaxies succeeds. Second, unsustainable resource depletion. Many civilizations may not self-destruct, but simply starve in their unsustainable growth, overexploiting their planet, unbalancing the climate, polluting oceans, and ultimately collapsing ecologically before learning to expand outward. Third, local cosmic catastrophes. Even a Type 3 Kardashev civilization might face greater threats. Random gamma-ray bursts from colliding black holes, X-ray storms from distant quasars, or collisions with large celestial bodies. These events, though rare, are potent enough to sterilize an entire planet or a small galactic region. If the filter is such cosmic events, a civilization must achieve interstellar migration and establish dispersed havens across multiple stars before disaster strikes. And with trends in astrobiology in 2025, scientists predict that artificial intelligence could be the new filter, where it replaces or eradicates organic civilizations before they expand, potentially leading to a universe dominated by silent machine intelligences. If the Great Filter awaits us, then every technological stride humanity takes is not a victory, but a step closer to an inescapable door of destruction. The silence of the universe is then not evidence that no one is out there, it may be evidence that all who went before us failed this ultimate test. As we examine recent scientific breakthroughs, the picture of the Fermi Paradox grows more complex and at times more disconcerting. Space telescopes like Kepler and the Transiting Exoplanet Survey satellite have provided astonishing data on the prevalence of exoplanets. We have confirmed thousands of planets beyond our solar system. The data shows that Earth-like planets in habitable zones may be the rule rather than the exception. The latest estimates indicate that our Milky Way galaxy alone could harbor tens of billions of planets comparable in size to Earth and situated in the Goldilocks zone of their host stars, where conditions are neither too hot nor or too cold for liquid water to exist. If planets suitable for life are common, then the factors in the Drake equation for star formation rate, fraction of stars with planets, and average number of life-supporting planets per system are all high, pushing the probability of intelligent life even higher, making the silence all the more inexplicable. Meanwhile, studies in astrobiology open doors to alternative scenarios. We are searching for carbon and water-based life, but what if intelligent life does not require carbon? Research into alternative solvents, such as silicon instead of carbon or liquid methane instead of water, reveals the diversity of environments that could nurture entirely alien life forms. If life can arise under harsher conditions than we imagine, like beneath the ice of gas giant moons, then the probability of life emerging is very high. But if life appears easily, then the great filter must reside in later evolutionary stages, meaning the progression from simple life to complex intelligence, or from intelligence to interstellar civilization, must be extraordinarily arduous. And the James Webb Space Telescope has delivered unprecedented detailed spectroscopic analyses in 2025. For instance, detecting helium flows on a superpuff exoplanet, where a massive cloud of helium gas is evaporating and streaming ahead of the planet as it orbits its star, or confirming no solid evidence for dimethyl sulfide on K218b, a planet once thought to show biosignatures, tempering initial hopes but reminding us to distinguish between biosignatures, which indicate biological processes like methane and oxygen combinations, and technosignatures, which are markers of technology such as artificial lights or industrial pollutants.
Recently, scientists are also exploring biosignatures in exoplanet atmospheres. Detecting a mix of methane and oxygen in an exoplanet's atmosphere could be a strong indicator of large-scale biological activity. However, if we find a planet with clear biosignatures but no technosignatures whatsoever, this further bolsters the notion that the Great Filter lies at the technological development stage. It would be a verdant world but intellectually barren. The closest real example we have is ourselves. We have existed as Homo sapiens for about 300,000 years, and about 10,000 years since the agricultural revolution. We have only been emitting detectable radio signals for less than a century. The lifespan of civilizations in the Drake equation may be an exceedingly small number. We are in our most vulnerable phase, technologically capable of global catastrophe, but not yet wise enough to ensure long-term survival. And a study from the Search for Extraterrestrial Intelligence Institute in February of 2025 simulated how a civilization like ours observing Earth from afar might detect our old Arecibo radar. But atmospheric signatures like nitrogen dioxide are becoming more detectable thanks to the James Webb Space Telescope, suggesting we are leaving traces visible across vast distances. Let us return to the Voyager's voyage. It carries not only greetings but another symbol, an illustration of a human couple, a male and a female, drawn alongside the double helix of deoxyribonucleic acid and our bodily structure. That is a detailed and coded message about our biology. If a sufficiently advanced civilization decodes the golden disk, they will understand what we are made of and what we are doing. But it is a message of cosmic innocence, assuming another civilization shares basic biological laws, a fundamental logic of communication, and most importantly, a value system that does not view us as a threat or raw material. Human civilization stands at a philosophical and scientific crossroads. If we choose the first possibility, the dark forest, we must immediately cease broadcasting signals and begin developing stealth technologies, masking our thermal and radio footprints from any external eyes and ears. If we choose the second possibility, the zoo, we need to focus on internal development, achieving Type 2 status as swiftly as possible, to prove our worth not just in survival but in extraordinary progress. Only when we are strong enough, complex enough, might we earn a glance, a nod from those invisible observers. But if the Great Filter awaits us, then all scientific endeavors, all philosophical debates, all political struggles become futile before the threat of inevitable extinction. The solitude we feel now may be our final stroke of luck. We still have time to recognize the peril before it arrives. And with updated post-detection search for extraterrestrial intelligence protocols in October of 2025, scientists are preparing for scenarios if we find a signal, including global coordination and crisis response, ensuring humanity responds with unity rather than division.
In the pursuit of discovery, the search for extraterrestrial intelligence community does not limit itself to listening for radio signals. Recent studies have expanded to seeking more advanced technosignatures, for example, searching for anomalies in stellar infrared radiation. If a Type 2 civilization is constructing a Dyson sphere, they would capture stellar energy and re-radiate excess heat as intense infrared. Projects like the Wide Field Infrared Survey Explorer have scanned millions of stars for such unusual heat signatures. But thus far, notable findings like the star KIC 846285 or Tabby star have been rationally explained by natural phenomena, such as enormous comet dust clouds. An emerging trend is hunting for larger-scale constructs, such as quantum signal emitters or interstellar laser communication grids. If a civilization wishes to transmit information efficiently across galactic distances, they would use powerful lasers, which focus energy far better than radio waves. Projects like Breakthrough Listen are employing large telescopes to scan billions of narrow-frequency channels in the electromagnetic spectrum, seeking modulated laser pulses with orderly patterns distinct from natural cosmic noise. To date, the results remain a disappointing void, but a study in September of 2025 examined interstellar objects like Oumuamua to search for technosignatures, as they could be probes, though nothing was found. It broadens our thinking about technosignatures beyond static signals to dynamic visitors. And so, our tale circles back to the essence of existence. If we are the only beings, if we are the universe's sole eyes, then our responsibility becomes unimaginably immense. 13.8 billion years of space and time evolution, from the Big Bang, the forging of heavy elements in the cores of first-generation stars, the coalescence of nebulae, the accretion of planets, the emergence of organic molecules, the self-organization into life, and the rise of human consciousness, all may be a singular chain of events serving one purpose, for some entity finally to open its eyes, perceiving the splendor and horror of the void. This solitude is both the greatest burden and the ultimate meaning. But if there is other life, even a tiny spark, then we are merely a sapling in an endless forest, a vulnerable species ever at risk of being overlooked or extinguished by forces beyond our comprehension. Yet their existence, though risky, also offers liberation from absolute loneliness. Whatever the answer, it will be a compass, utterly reshaping humanity's developmental path. And with predictions in astrobiology for the latter half of 2025, missions like the Habitable Worlds Observatory could detect additional biosignatures, sparking deeper discussions about whether we are searching for life incorrectly, as it may not be carbon-based like ours, potentially thriving in silicon substrates or exotic chemistries we have yet to imagine.
At this moment, Voyager 1, our farthest and oldest artificial object, continues its solitary journey through the frigid darkness. On the golden disk affixed to its hull, there is a message recorded in Mandarin, a hastily prepared greeting from the 1970s when optimism about the future seemed boundless. We wish you good health. We miss you very much. If you have time, please come visit us. Perhaps in tens of thousands, even millions of years. Some civilization will chance upon this bottle in the spatial stream, or perhaps never. But by launching the craft, humanity has accomplished the most vital act. We have sent our voice into the cosmos. We have declared our existence. We have proven that in this seemingly dead and silent universe, at least one civilization once existed, once contemplated infinity, and dared to wave towards the stars. And perhaps that very act of waving, the courage to face the silence, the unceasing quest for meaning, is the true essence of life. When you gaze deep into the cold abyss of space, the abyss gazes back with emptiness. But when you look up at the star-filled sky with all your doubt and hope, perhaps in some moment, those stars, or their hidden inhabitants, are gazing back at us, listening to the whispers of a generation striving to define the meaning of existence in a bottomless sea. And with discoveries like the gamma halo from Fermi, or the helium flows on superpuff planets from James Webb, we persist in hoping that one day, the silence will shatter, ushering in a new era where humanity is no longer alone.